So, good morning, everyone. A very warm welcome to all of you. First of all, a very happy new year to everyone. I am Manu Sharma, field technician and sales executive in Labosport India. It is my pleasure to host today's webinar on the topic importance of quality and control in sports surfaces. So the purpose of this webinar is to give insights how important is quality and control in sports surfaces, how it can affect athletes' performance. So over the next 45 minutes, we will be hearing from our esteemed speaker, Professor David James, who bring rich experience on this subject. But before we begin, just a few housekeeping points. So this session will last for about 1.5 hours, including Q&A session at the end. Feel free to type your questions in the chat box so that we will address as many as possible towards the end of the session. The recording of the webinar will be shared with participants via email after the webinar. So now I would like to welcome our speaker, Professor David James, who's currently the CEO of Labosport Group. So Professor David, over to you.
Okay, thanks so much, Anuj, and thanks everyone for turning up to this webinar today. This is the first webinar we've done for really focused on the Indian market and the Indian region, and I hope we will be doing many more over the years to come. So I'll share my screen and we can get going. Okay, can someone give me the thumbs up? Can you see the screen? Okay, we're all good. So yes, the topic of the webinar today is elevating synthetic turf and the importance of quality control in sports surfaces. I hope this is really interesting and relevant for you. I think it's a fascinating topic. And I guess I don't know if it will take an hour and a half, but we'll take the time it needs to go through this topic thoroughly for you today. Lots of time for questions afterwards, so please do write any questions you have, and we'll work through them at the end of the session. So my name's David James. I'm an engineer by training, and I am immensely proud to be the CEO of the Labosport Group. I've been to India many times. I think I was in India at least twice in 2025, and I know a bit about the country and the market and the climatic conditions and your love for sport as well. Okay, so to begin with, I just want to say a few words about Labosport, how we're organised, what we do, why we exist, and then we'll focus in on synthetic turf quality issues. Okay, so let me have a look. So, in essence, what Labosport does and why we exist as a company is we are here to de-risk projects. We're here to make projects safer for the people who are building the sports fields and also for the players. So we're in the business of risk management, effectively. And what we get involved in typically is when there's a new sports facility being imagined anywhere in the world, we might get involved in some of the sort of design and tendering and project management processes. We call that consultancy. So we get involved in designing sports fields and stadiums all around the world, kind of coming up with a feasibility plan, understanding the ground conditions, planning a good project, helping the field owner sort of come up with a specification for what they need, and really guiding the end users through the whole process of how you might imagine building a sports facility. I mean, they're large, expensive projects that can take many years to reach to conclusion. So we get involved in the design and tender process. We get involved in the construction phase. So as a field is being built, we will monitor the quality of the construction, the materials that are being used on site, the depth of stone and so forth, and all these topics. And then we also get involved in testing and certification of that field once it has been constructed. So what we tend to do is we get involved sort of at every stage throughout the life cycle of a sports field. And we've been doing this as a company for 33 years now. And we're the largest company in the world of our type doing this type of work. It's very important to say we never get involved in actually building a field. We are the independent kind of consultancy expert and test laboratory that helps advise and doing the quality control on these projects. We don't get directly involved in construction, and it's very important that we keep our independence from that topic. Okay, so as I said, we've been going for 33 years, and we've been very lucky. We work with federations, international federations and national federations all around the world, in many different sports as well. So, really, if there's a human running on a surface or a ball bouncing off a surface in sport, it's very likely that Labosport has been involved at some point, working with the federation to help them maybe establish standards, maybe working these federations' tournaments and their World Cup events and so forth. And we do that for international federations such as FIFA, such as say World Rugby, FIH for hockey, RNA for golf. We work with these international federations, but we also work with local national federations like the Dutch Football Association or the French Rugby Association or so forth. So we have this network of connections all around the world, and we most of our work is actually based on recreational sport, so sport for communities and municipalities, for schools, for local authorities and cities, for people like you and me. That's where most of our work is focused, actually, on sports facilities for sort of everybody, really. But of course, we get involved in the elite tournaments as well. And here we've got some examples of recent football and rugby tournaments and competitions that we've been involved in. So specifically, say, like the Asian Football Confederation with their consultant, and with the Rugby World Cup. We're the main consultant for the Rugby World Cup in Australia. We do loads of work for the Paris Olympic Games and the Women's World Cup in recently in Australia and New Zealand. When there's a major tournament going on, we're involved, really helping on the planning and the testing of the different sports surfaces that are being used, whether it's the athletics track, the hockey field, or the football pitch, or whatever the topic is, really. So yeah, I'm hugely proud to be leading this company. I do it from a position of, I suppose, technical expertise from my background. I'm a professor of engineering myself, and I'm an academic. And this has been my topic in sports engineering for, really, I suppose I completed my PhD 25 years ago in this topic. And since then, I've been working really hard to, really understand what's going on in sports surfaces, really understand how humans interact with sports surfaces and so forth, and how we can make better sports surfaces for our users. We've got a global footprint at Labosport. Okay, so we're not the world's biggest company, but in this industry, we're quite large. We've got 155 staff based all around the world. So from the Americas, right the way across the world to New Zealand, as I look at the world map. So we are headquartered in France, and we have, I suppose, the majority of our offices are in Europe. So we've got, offices in the UK, in France, in Italy, in Portugal, in Turkey. And then, we've got a large presence in Asia, where we have our teams based, in obviously in Delhi with our team with Labosport India, but we've also got teams in China, in Malaysia, Thailand, Australia, and New Zealand. So we cover the sort of the whole Asia Pacific region with our different teams and staff and offices and so forth. Yeah, so it's a sort of a small multinational. It's a great place to work, and it's really exciting. And the reason we have these different offices of Labosport all around the world is because we need to be close to our markets. We have to be close to the sports fields that we're testing, and that we're controlling and measuring and planning and designing and so forth. And something I didn't say before is Labosport. We really do work in all the different types of sports surfaces that we see. So natural turf. Today we're really focusing on synthetic turf and quality control on synthetic turf, but natural turf is a huge topic for us. About not quite half, but maybe 40% of what we do at Labosport is on natural turf. We're looking at really the agronomy of how grass is growing, the root zone design, working in the golf industry and football and rugby, and so forth, and lawn bowls and different topics. So and in cricket as well. My background's actually in cricket and how cricket balls bounce. So natural turf is a huge topic for us. We're not just synthetic turf. We cover all bases. But today we're really focusing on synthetic turf. Okay, so. The final thing I'm going to say about Labosport before we really get into the topic is about, I suppose, some of the key relationships we have with the federations. So we're very proud to be a FIFA research institute. What this means is we're one of a very few number of laboratories or universities in the world which have been sort of selected and have qualified to become a FIFA research institute. And through this role, it means that we can sort of carry the FIFA badge next to our name. So FIFA and Labosport can sort of appear together, and that's really quite a mark of real respect of us from the world's governing body of football. And what it means is actually we FIFA rely on Labosport to give them knowledge, understanding, to undertake research projects, to help them understand what is going on, specifically in synthetic turf, but also natural turf for football. And we've done quite a number of large projects for FIFA through this special partnership that we have as a FIFA research institute, and it gives us that real great knowledge and understanding of really what's going on in sports surfaces. Okay, so if we jump into the main topic, let's talk about synthetic turf, and just a little bit of history about synthetic turf before we talk about quality. I mean, synthetic turf was really first sort of used in a tournament in 1966 at the Houston Astrodome. Okay, so this is an indoor multi-sport stadium. There's a picture of it on the slide, and you can see it was an indoor stadium. Obviously, that presented major challenges for growing grass, particularly in 1966 when we didn't have the grow lamps that we have today. So obviously there was a strong motivation then to be able to use a carpet of some sort that wasn't natural grass, and that's really when I suppose synthetic turf was first conceived. So coming from America, and the initial name of it was chem grass. Okay, and that wasn't really wasn't great in the market. The idea of a chemical grass, I think that kind of put some users off, and actually the name was then the name of the product turned into AstroTurf because it was from the Astrodome Stadium. Okay, so that's where this kind of idea of AstroTurf comes from. But it's very important. AstroTurf is just one. It's like the name of a product. It's not the name of the of what synthetic turf is. So a lot of time people you get confused between AstroTurf and synthetic turf. AstroTurf is just one brand. It's one company, one product. But sometimes people kind of think it reflects the whole of the industry. Okay, so 1966. That's when sort of the AstroTurf idea came from. But it was a very short pile nylon system. It did work. It had some good attributes. But for example, if you were playing football, soccer on this product, the ball bounce would be quite high, the ball roll would be quite long, and if you fell over, it would be likely that you may get a skin injury on this very early product. Okay, but there was something about that synthetic turf back in 1966 that was a great idea, but people could immediately see that if this product could be developed, it would have huge impacts for the world of sport, because you can use it in locations where you may not be able to grow grass, like for example in an indoor stadium. Okay, so today we sort of roll forward by 50 plus years, 60 years, and synthetic turf has evolved a huge amount, and it's a complex product. It's an engineered product. There's been masses of research and development that have gone into different types of synthetic turf for different sports to understand all sorts of different features of turf, the human surface interaction, the player surface interaction, the longevity of the turf, the resistance to ultraviolet light, the resistance to harsh climatic conditions, dry, hot conditions, cold, frozen conditions. There's been huge amounts of work that have gone on into this product over the past 60 years or so. If we think about, I suppose, some of the key benefits that we see, and why many people choose a synthetic turf product, it's typically because synthetic turf, well, the main thing I think is that it can just withstand so much more usage than natural turf. So if we compare synthetic turf and natural turf together, they've got different characteristics. They're a different product. And again, just to remind, at Labosport, we do both. Sometimes we think a natural turf field is absolutely the right solution. Sometimes it's a synthetic turf field. And I think it really depends on the usage and the end users that we've got, that we need, that want to use this system. So, but, synthetic turf, we typically can have 10 times more hours than natural turf. So it depends where you are in the world, but I'll give an example from Europe. That's where I am today. At this time of the year in Europe, a natural turf field can only withstand maybe 5 to 6 hours of, say, football every week. Okay, so that's not even a match every day, because the grass needs time to recover. The ground conditions need time for the drainage to work, and basically the grass needs the opportunity to recover with relatively low levels of light and relatively cold conditions. The pitch can only withstand a few hours of football every week. Otherwise, you will have major problems and the field will fall apart. Synthetic turf fields this time of the year, typically we're getting 60, 70 hours of football being played in them, potentially even more. And we see this and we know this as a fact, because we can see all the usage statistics, and even many fields have got cameras on them where we count the number of players who are playing. And we see just a huge amount more playing hours on a synthetic turf field than a natural turf field. You still have to do maintenance on both. It's very important to say, but that just the number of hours you can have are just a whole magnitude higher on a synthetic turf field. So it makes it very good for community use, over for high intensity uses, for a municipality, and so forth. It makes it a very, very good surface. It's an all-weather surface. So synthetic turf, whether it's cold or hot or wet or dry, they tend to behave in very similar ways. They're very consistent and predictable. Okay, and that is not the same for natural turf fields. A natural turf field will be very different in the middle of summer to the middle of winter. Um, Modern hybrid natural turf fields are more consistent because they've got a special engineered designed, they're built on sand and so forth with stitched fibers in them. Um, but even still, a synthetic field is really, we consider it to be sort of almost like an all-weather surface. Okay, if it's extremely hot or extremely cold, perhaps not. But for most people, mostly around the world, it's a great surface for harsh climatic conditions. I think I mentioned it before about the maintenance. You have to maintain a synthetic turf field every week. You've got to brush them every 6 months, decompact them and so forth. So there's work to be done on a synthetic turf field, but it is significantly lower maintenance inputs, the energy inputs for the maintenance, the time, the staffing costs, and so forth to do the maintenance than a natural turf field. So there's savings there, and what we tend to see as well is synthetic turf fields are typically used as a revenue generating asset. So what people tend to do is they will if you're a field owner, you can get a synthetic turf facility. You can then maybe effectively rent it out by the hour to different users, and you can create a business from that synthetic turf field because it's predictable, it's always there, it can withstand the traffic, and that's perhaps different to a natural turf field where it's harder to have a revenue generating asset from that natural turf field. So we see differences between the field types essentially, and I'm going to talk about all the different testing we do soon, but it's just to say, we know over the last, say, 60 years or so, that synthetic turf, if it's built correctly, if it has the right characteristics, it can provide very good sports performance and very good player safety. There have been endless studies comparing the injury risk on natural turf versus synthetic turf. And for sports such as soccer, football, there's no difference in the injury rates between the different surface types. This is a topic I've studied extensively myself and have written on. I've read all the papers, and really there's no elevation of injury risk on synthetic turf, say in soccer, and as comparison to natural turf. It's really is a proven technology. Okay, so let's talk about how we do a quality control process. So the way the world of sport works is we have, I suppose, international sports federations. Okay, and they try to control, I suppose, the rules of their sport. So if we take, say, field hockey, so the FIH are the International Hockey Federation. Okay, and they organise the international tournaments, World Cup events, and so forth, and they also control the rules of hockey. Okay, and including the playing surface, the hockey sticks and the things like face guards for players and for goalkeepers and so forth. So they have a whole range of rules and documentation that they create and maintain every year. And they have a standard for playing surfaces for different levels, from elite, we might call it sort of global kind of hockey systems, where you have these kind of water-based, really elite systems. We've now got innovation products for dry turf hockey systems, and you've got more sort of local, national level hockey systems, sort of sand-based systems for slightly lower kind of community play in hockey. And each so you've got the different standards for each surface type within one sport. There's a big, thick documents and test manual that the FIH produce and maintain to describe the standards, the different characteristics that that surface needs for the sport. And we see this across all sports. We see it in football, we see it in rugby, we see it in cricket, we see it in American football, we see it in indoor, in basketball, and so forth. Whatever the surface is, normally there's a sports federation somewhere that's kind of described the characteristics of the sports surface that's needed. And in World Athletics, for example, the World Athletics have a big manual where they describe what the playing surface should be, what the athletics track should be. So we have these international federations setting the standards. We also have organizations like the CEN Committee, the European Committee for Standardization. We have things like the ASTM, the American American Association for Testing Standards as well. And then we have other test standards around the globe as well, like, in Australia, they've got some standards. In New Zealand, they've got some different standards and so forth. In France, they have standards. In Italy, they have standards. So you have these international standards, you have these national standards, and then also we have things like our trade associations as an industry. So like the Synthetic Turf Council, where we have guidelines for how, what turf should be, the different characteristics we're looking at. So there's a whole network of different organizations who write standards for sports surfaces. And again, Labosport, we're very proud. We basically are on all the committees. We go to all the meetings. Often I go personally, and to help maintain and improve the standards, both in terms of the thresholds, the numbers we're looking for, and also the test methodologies as well, how we test the systems as well. So this is quite a complicated, big world of standardization, right? So let me talk you through a typical process of how a synthetic turf field is how we maintain the quality control on that field. So the first thing that happens is a product will come into a laboratory, an accredited test institute somewhere in the world. Obviously, Labosport, we've got our laboratories all around the world. So if you're a company that is making synthetic turf, the first thing you need to do is you need to get the product approved. So the product, your turf system will come into a laboratory, and it will undergo a really quite a rigorous series of testing in the laboratory. Okay, and that is to approve that product type. So say maybe you've got 5 or 6 different products in your company. Each one would need to have a product approval in the laboratory first. And I'm going to go into the details of what we do there in subsequent slides. But essentially, we're really rigorously checking that product for all sorts of different characteristics. Once the product has been approved, you can then go and install that on hundreds of different locations and fields, because the product has been approved as a product. You can then go and install it somewhere. So once you've got the product, typically you're building the field, you've chosen that synthetic turf product or that system. Okay, you're then going to start your construction phase. So again, we will always advise that there are kind of construction quality checks during the build. So we will typically, what we do is we check the stone that's being used, the depth of the stone, the strength of the sub base, the infiltration rate, and so forth. I'm going to come onto these in details later, but we check what's actually being built under the ground before we get to the surface layer. Okay, once the field is built, we will go and do a on-site inspection of that field to do all the final sort of certification testing, and that means that field can get a certificate from one of the federations, say hockey or football, that gives it a certain level that maybe allows that field to be used for tournaments because it needs a certain level of certification. Okay. And then whilst the field is slowly getting established over the years, typically what we do is we go back to that field to perform periodic performance inspections throughout the lifetime of a field. A typical synthetic turf field, we can get, I mean, it depends, but 10 to 13, 14 years, depending on the usage, the climatic conditions, and the maintenance on it. Okay, that all affects the lifetime of the field a lot. But typically we'd want to go back and check the quality of that field, particularly as it's getting older, and is it still safe? And does it still meet the international federation requirements that we need for good sport? Okay, so let's go into each stage in a bit of detail. Okay, so this is the technical aspect of it. So a product comes into the laboratory, a synthetic turf product, and what do we actually do to it? Well, it's a I'll be honest, it takes about 2 weeks of full-time work from maybe 2 technicians to test a product every day, for at least 10 days of work. They're doing different tests on this product. It's really quite extensive what we do. Essentially, we're looking at how this product, how it withstands artificial aging. So you can see in the top pictures here, this is the Labosport XL. So this is a machine which creates artificial mechanical aging of the product. So what we tend to do is a product will come in, we test it when it's brand new, it's a totally new condition. We put it through the artificial aging machine, and then we test it, say, after 3,000 repetitions and after 6,000 repetitions of this kind of artificial aging. And we see how the performance characteristics, so things like how the ball bounce or the ball roll, how that changes as we age the product. And of course, we're looking for products which they don't just behave very well when they're brand new on day one, they will also still be performing well after 5 years, after 8 years. Okay, so the Labosport XL, we think it can create an artificial aging of around six to 7 years, depending on the climatic conditions. So we've got a really good tool to check the longevity of the product. We test a whole range of parameters here. So yeah, the ball interaction things you can imagine, ball rebound, ball roll. We test the athlete interaction topics. So we test the traction, the grip of the surface. We test the what I call the vertical compliance of the surface. So that's I suppose how an athlete, how hard, how soft it feels, and also how springy the surface is. We have the advanced artificial athlete to test that. We look at topics like the skin injury risk. So there's a picture here of the Labosport. This is a device which measures the effectively the friction of the like a test foot that moves around the surface. It rotates around, and we measure the frictional forces, and that gives us an idea of the skin injury risk of that product. We test things like, we call it the splash. So if the system has infill in it, and I haven't talked much about this, but when we talk about synthetic turf, we really have to talk about the system. Okay, and typically you have a carpet, you have a shock pad layer, and a sub base. But we often have maybe infill inside the carpet. Not always, but in the majority of times. And we want to measure how the infill, how it is contained in the carpet. So we do this so-called splash testing, and you can see an image there of the ball coming in, and we actually measure the volume of the splash at its peak. And we want to have systems which actually contain the infill and reduce the amount of the splash of the infill, because we think that's good for the sport. It's actually also very good for the environment, because we don't get infill kind of migrating off the field as well. We do a lot of testing for UV, so ultraviolet light. So how well will the carpet perform under very intense light? And we know that if the manufacturer has not used the right amount of UV stabilizer in their so-called the master batch in the plastic, you may have problems on the field. And we also do important in this, we will check the identification. So we do a product identification. So we check, we almost do, it's like a DNA fingerprint of the plastics and the components that have been used in the field. We do simple stuff. We check the stitch rate of the carpet, but we also do this, quite advanced techniques, the so-called DSC method, and a TGA method, where we're melting we take samples of the polymers, we put in through a special machine, and it basically tells us the melting points of that polymer, and that's like a fingerprint for the polymer. It tells us exactly what that polymer is, so we can identify it, and that's a key point, because when the field is being built, we want to make sure that the same product that was approved in the laboratory is actually being delivered on site as well. So when the field is being built, like I said, it's not just the carpet that's important; it's everything underneath it as well. The sub base is really critical as well. So typically, we will go out and visit the fields. A test laboratory, not much us, anybody who's involved in this industry. We'll go out and we will check the quality of the construction. So the quality and the volume of the stone aggregate that's being used. If the field, many sports fields, that they're not just completely flat, they will have a slope on them for the drainage. Okay, so we will check the levels, the slope. We also check the planarity. So is it level, or does it have any undulations in it? This is during the construction. Okay. We will check things like the surface modulus. So that's the stiffness of the sub base. We have many devices to check that. We can do it with like a deep cone petrometer. We can do it with the so-called Prima, or the lightweight deflectometer device, where we can check how stable the stone layer is, which is very important afterwards as well. We check the infiltration rates. If there is a shock pad that's being used, we might check the quality of that shock pad as well, and then maybe the levels of that shock pad as well. So if you can get these bits right, and everyone always tries to build a good field, right? But we have tools to go and measure it really accurately to see if it's going to be precise enough. I think it's really important, and if you've got a field like for hockey fields, you need to have a very precise levels, very level surface, because the hockey ball is relatively small. You have to have a very good surface to play good hockey. It's really important that you get the sub base right. And like I said, we just have tools that allow us to do that testing really precisely. And we can then work. If there's a problem, it can be corrected, because it's a nightmare if you move past this construction stage and you put a carpet on top. It's very hard to then go backwards to rectify it afterwards. So it's really important that you get this stage right. When we have actually, so the field is kind of complete, the construction is completed, what we will then tend to do is go and do a certification test. So sometimes even before the field can be used by the athletes, we need to get it sort of certified. Sometimes that's a condition of maybe the tender or the construction project or so forth, or maybe sometimes just the field user wants to have the product certified, so they know that it's met the highest standards from the world of sport. And typically, what we do, the first thing that we do, and I mentioned this just a few seconds ago, is we check that the product that has been installed, the actual carpet that's been installed, is the same carpet and system that was specified, that you thought you were buying or thought you were delivering. Sometimes products get confused. Sometimes people might install the wrong thing. And so it's really important that the field user knows that what has been delivered and built on site is what was specified. So again, what we do is we actually take samples from the field we take samples of the yarn, we take samples of the carpet, we check the stitching rates, we do this DSC test again, we do this fingerprint of the polymer to check that the polymer that's been used on the site is the same that was tested and approved in the laboratory. We test the TGA, we check the quality of the sand. We do this whole product identification piece to check that what is there is what was specified. And if that's good, we're all good then for the other tests. So we test all the player surface interaction tests. So the rotational traction, the so-called advanced artificial athlete here, we drop a mass onto the surface and we check things like the shock absorption qualities, the deformation of the pitch, and also the energy return, how springy the surface is. And again, different sports have got different requirements. Okay, so not all sports are the same. They require a surface to have different characteristics. So we have these tools, and then we have certain target thresholds. So, for example, on the rotational traction, we want to know, we want the peak torque between say 25 Newton meters and 50 Newton meters. So there's a target range where if the measurement falls within that range, we believe that this means that the surface will be good for the users and for the sport. And actually, even within one sport, if you take football controlled by FIFA, we actually have 3 different quality levels, right? We have FIFA Basic, we have FIFA Quality, and we have FIFA Quality Pro. And actually, what typically happens is, as you get to the higher levels of certification for, say, international tournaments and really elite play, the target threshold for the parameter you're looking at gets narrower. So they become very well controlled. We have a very specific characteristic that we're looking at. So for example, the target range for traction is lower, say at FIFA Quality Pro than FIFA Basic. Okay, and it means we have to be more precise with the field, get a very specific characteristic for a target that we're looking at. Okay, we measure the field dimensions. It sounds kind of obvious, but really the field needs to be built. Sometimes there's a range of the dimensions for a field, but it's really important that we know how big the field is. What is the size? We look at the planarity is a really key thing here. So, are there any undulations in the fields? Okay, are there any dips or bumps? And we've got limits about what is okay and what is not okay with that. We may even look at things like the head impact criterion, particularly for rugby. When players go to the ground, we do an impact test which simulates a head hitting the surface, and is it likely that a player will get concussion or not? We do that testing, and obviously all the ball testing as well. The ball roll length, the ball rebound height. You don't want the for football, you don't want the ball to roll too far or too fast, and you don't want the ball to be too bouncy either. You want the surface actually to behave quite like natural turf. And actually, it's a good point to say here is that many of these target thresholds, the different characteristics that we're looking for, many of them come from, I suppose, baseline data that we've collected on natural turf fields. Because we know how a good high quality natural turf field behaves, they are kind of used as the targets for the thresholds for our synthetic turf testing. Okay, so you've gone through this whole process. The field's been certified. It passes everything. That's great. If it doesn't, maybe you have to go and we have to make some changes to the field design, change the amount of infill or something like this. And hopefully, we can work with whoever's building the field and get it to pass. So you've got your field. It's got the certificate. That's great. You've now got a certified field, and I think that's very good for reassurance for the quality of the field. But also, it might mean that you can participate in certain tournaments, or so forth, depending on whatever sport it is that you're looking at. Okay. Then I think, I'll just talk about this. I think there's huge value in doing periodic inspections for your field as well. So different sports have got different recommendations. So if you go soccer, we've got the soccer example here. Every 3 years, so you get after you've got your initial certification for your field, that will expire after 3 years, because after 3 years the field will have changed quite a lot. You might have had a lot of compaction. If you've maintained it well, it should be great, right? But if you haven't, you might have problems with the arms, maybe the infill's moved, and then that field is no longer in scope. So we go back typically after 3 years, after 6 years, and to do retests to check if that field is still meeting the requirements for the sport. In rugby, it's every 2 years, because in rugby, the playing surface, we've got a specific issue around concussion and head injuries in rugby, and we want to be really sure that that surface is safe to play rugby. So this kind of periodic inspection is really important. I think it's also really interesting to see how the field is changing over time. And actually, if we collect data on that field periodically, every couple of years or so, actually it really helps drive good maintenance on the field. If you know that the field is suddenly becoming too hard, or maybe the ball rebound height is now too high, it's a really good indication of the type of maintenance that you need to do. Maybe you need to do a decompaction type maintenance. Maybe you need to top up the infill or something like this, and that actually extends the lifetime of the field. Again, just remember, a typical sports field, synthetic field with sub-base, with fencing, with lighting, it could cost as much as $1 million. Okay, so these are significant investments, and if you maintain it right through testing and maintenance, you can extend the lifetime of that field up to 10-12 years, and that's much better than no testing, no maintenance, and the field is dead after 5 years and you have to replace it. Okay, so the testing and the maintenance, make sure you've got high quality, but also make sure that the field lasts longer, and that's ultimately a much better investment for everybody, right? So the testing, regular testing helps the maintenance, and that drives increases the lifetime of the field. One of the things that we see where fields typically fail, when we know that they're reaching the end of their life, is when the yarns, the plastic fibers become flat over time, just through usage, through UV. They get tired. They sort of lose their resilience and their stiffness somehow. And what can then happen? I mean, you can rejuvenate it with good brushing, with good maintenance and good infill. You can get the fibers standing up again, but after a time, they do become very, very tired and they become flat. Okay, and then what will happen is the ball roll distance will become longer than we really want in the sport. So actually, ball roll distance I think is a very good indicator of how the field is getting old, and in a way we can even use the data to predict when we think it was reaching the end of its useful life. Okay, so thank you for that. Again, I'm just going to recap to the basic process here again to reiterate this. So the quality control piece, right, has multiple different stages. Okay, and we talked about the product approval in the laboratory, so how products get tested in the lab, the sort of things we test, why that's important. We then talked about during the construction of the field, the so-called key stage inspections, checking that the sub-base is being built correctly, it has the right characteristics, the right type of amount of stone, the right drainage amounts, the right levels. Okay, we talked about that. We then talked about the completion tests we do on site. Okay, and then we also talked about periodic inspections as well. So I think it's a whole process there um, that if you want to make the most of your investment, say this maybe like $1 million you're spending on this sports facility, I think it's really important that you follow these basic quality control processes to make sure that everyone involved in the project is providing the best products and also building the field with real care and attention. And if you get that right, you'll end up with a great sports facility, which will drive, enjoyment, economy, performance. Everything will come with that if it's built in the right way. Okay, so thanks ever so much. I'm going to come out of the presentation and see if we've got any questions.
Yes, David, I'm jumping in. We actually have one question from Prabhu from Japan. He's asking, does it withstand temperature winter to minus 15 degrees sometimes and summer heat as well?
Yeah. So I mean, I think I said before, we call them all weather surfaces, synthetic fields. But look, if it's minus 20 or if it's plus 50 degrees, you're kind of at the limit of what we can do. Also for the players, let's be honest, if it's really cold or really hot. So what can we do? Well, I would say it depends on the synthetic turf type. Okay, so we know that actually, if you use a polymeric infill, like an SBR infill, it's actually really resilient in cold weathers. It doesn't freeze because the plastic does not absorb any moisture. The surface won't freeze. A natural turf surface will be totally frozen with those temperatures. Okay, but the SBR doesn't freeze. The recycled tires that we use because they don't absorb water. But it depends on the system. We have particularly now a lot of organic infills are being used in synthetic turf, and we know that at very low temperatures they will freeze, and that can mean that they may be unusable. I mean, in Scandinavia, people use them a lot, and they even install sort of underground heating basically for the synthetic turf so they can use an organic infill. But yeah, I'd say it's better. It's complicated. I'd say polymeric infills are better in low temperatures. In a way, organic infills might be better in high temperatures. So if you've got like a cork infill or a pine infill, like an organic infill, they tend to be cooler when it's very, very, very hot, but they freeze when it's cold. So you've really got to pick the right system for your climate. There's no, and that's why it's good to use an expert and a consultant as you're building your specification, because different systems will perform differently in different climatic conditions. Okay, great.
Another question. After so much of quality assurance replicating all the features of natural grass, why at the end international games and matches are being played on natural grass?
Yeah, so it's a great look. Again, just to be very clear, Labosport, 40% of what we do is in natural grass, right? I'm not here saying that synthetic turf is better than natural grass or natural grass is better than synthetic turf. They have different characteristics. Okay, they are different surfaces. Players do like elite natural grass. Okay, but to have an elite natural grass surface is very expensive. It can withstand relatively few playing hours per week. It cannot withstand harsh climatic conditions. So if you are playing at the World Cup, okay, we can invest millions and millions and millions in getting a lovely natural turf surface for you. But that will not be available for the vast majority of players because the amount of land you need and the amount of energy inputs to create that natural turf playing surface is very high. And so, okay, if you're at the elite, if you're at the Olympic Games, if you're at the World Cup, fine. We have a natural turf playing surface. If you're in the Premier League, fine, have a natural turf playing surface. But if you're at a mid-level of competition, or if you live in a country where it's too hot or it's too cold, then synthetic turf is absolutely the right way to go. They've got slightly different characteristics. One's plastic, one is natural turf. They are different. Of course they are. I'm not going to say they're not different. But, you know, not everyone can play on elite natural turf. The amount of water you need, the amount of fertilizers and energy, the time it takes, also the fact you can only play on them for like 6-7 hours a week, not 70 hours a week. You know, there are big differences between these surface types. But for sure, I mean, I could go into the whole biomechanics of the differences between the surface types, and I've done lots of work on this. They have different characteristics. Okay, natural turf has a very it can dissipate lots of energy because it has quite a deep profile. The way energy moves in the natural turf, it's quite a plastic surface. It's not very springy. Okay, so when you have an impact on natural turf, it's quite a dead surface, and players actually like that kind of dead feeling. Whereas a synthetic surface, because it has polymers, it's viscoelastic, has a higher energy response. So look, they just, from an engineering perspective, they're just different surfaces, and they've got different characteristics. Well, I'm not, but they have, some are better for one case use, others are better for other case uses. Again, it's a bit like, I think this is a really good example. It's a bit like say talking about cars, right? You can imagine an elite hybrid natural turf surface is a bit like a Formula One car. It's extraordinary. It's incredible performance. It's amazing. It's the fastest car in the world. But you wouldn't use that for everyday training, or you wouldn't use that for driving around normal roads, would you? You know, you might want a BMW or a VW car or something like this, right? You know, and that's what a synthetic turf surface is. It's a very good sort of everyday use for every trade training surface. And I don't, but you wouldn't say one is better than the other. It depends what you're using it for, right? That's the key thing. Yeah, right.
All right. We have another question from Colin saying, thank you for the lovely presentation. Is there a report that Labosport can issue for harsh climatic conditions, such as heavy monsoon, as well as hot and humid or hot and dry Indian summer conditions?
Yes. Yeah. So I think a good the two things we do for this, there's a new infill standard which we worked on and helped to develop with the SEN committee, the European Standardization Committee. And as part of that infill standard, we do there are two tests which are really relevant. Number one, we do the like a buoyancy test. So how likely is it that the infill will float, or will it, which is a key thing in monsoon, right? So for monsoon, you want to know two things really. What is the drainage capacity of your system? So we test drainage and infiltration rates, okay? But then you want to look at like the floatability or the buoyancy of the infill, you know? And actually, I'll be honest, if you've got a very heavy monsoon condition, you want to have infill which will stay in the carpet and not just float and get moved away or displaced. So we have tests for that. We also have tests for what we call permanent agglomeration. So if you have an infill, and we saw this in some climates with some types of infill, the infill will actually get so hot it can start to stick together. Okay, and you can then get clumps of infill with low quality products again. So we have tests for the infill to check that it won't do this under very, very hot conditions. And then obviously we've also got testing for you know, the how well the yarns will withstand to UV, to extreme sunlight. Will they fall apart? Yes or no? And also we have we do a heat test as well, where you build the whole system, we put it under lights, and we check how the temperature is elevated within the system as part of the lab approval test. There's a whole range of tests actually that we do for this to make sure that and we see different performance. Some products will perform much better in those climatic conditions than other products. So again, you've really got to buy the right product for your environment.
All right. As a second part, you already covered the subject, but does Labosport support the FIFA certification process for products? For instance, if as a turf manufacturer, we would like to apply for FIFA approval of the product, would Labosport support that process apart from the testing of the product itself?
Yes, yeah.
Definitely.
Yeah, we have we test, I mean, 1,000 different products a year in the laboratory from all the leading manufacturers, and we do the product approval in our labs, but we also help the manufacturers. We guide them through the process. It's quite a complicated process, so we're independent. If the product doesn't work, it's not going to pass our testing because we uphold the highest standards. But we help manufacturers. We explain what's going on, and sometimes actually we've got great advice with our team about how the product system needs to be changed. So I've used this word. You've got the carpet, but you've also got the amount of sand, the infill, the shock pad. All this works together as one system. And if it's failing on an aspect, sometimes we've got great experts in our team who can advise about maybe what needs to be changed, ideas about how the system needs to be improved or whatever or amended to make it past the requirements. Yeah, we do that extensively.
Also, we had one question about if we can elaborate on FIFA Basic certification.
Yeah, okay, FIFA Basic, this is great. So we're getting really technical here into the weeds. So FIFA Basic is a new sort of concept. It's still quite new in FIFA. It's only been around maybe for the last 2 years. So as an idea, it's been around for a while. We have 3 levels in FIFA. You've got Quality Pro for like elite stadiums and tournaments. Okay, you've got FIFA Quality for the vast majority of use, like municipalities, universities, schools, training centres, national kind of sports centres, this kind of stuff. But you've also got FIFA Basic. Now, FIFA Basic, I suppose there's two key uses here. One is when, say, you want to have a tournament, play a football competition, okay, and you want to play it, and you think you've got a good synthetic turf field, but the turf wasn't actually approved as part of the whole FIFA certification process. It exists there, but you think it's okay, right? But it's not an approved product. What we can do is we can do a FIFA Basic test on it. We test essentially the playing properties of the system, okay, and we can then give effectively a temporary certification for that field under what we call a FIFA Basic certification. We can't give it a longer accreditation because we can't do all the all the mechanical aging tests or the UV aging tests on this product as well because it's already been installed. We don't know what it is, but we can test if it's good for play, if it's safe for the players. Okay, so we can test the ball roll, the traction, the rotational resistance. We can test the vertical compliance. We can check the consistency across the field, and that will mean that it can be we can give it a temporary certification as FIFA Basic, and that means you can use it for a tournament or a competition if your tournament or competition requires FIFA accreditation. Okay, and that's actually in the laws of the game of football that you can do that. The other case use actually is for slightly smaller fields. You can have a FIFA Basic certification on a field that doesn't have the minimum dimensions for a normal FIFA field. So it gives a bit more flexibility on that for these test cases. I've got actually I know we've got Anuj on the line. Have I covered FIFA Basic properly there, Anuj?
Yeah, so for FIFA Basic, basically, recently they revised, this guidelines for the dimension. So earlier they kept it very low, but now it's, I think, length is just around 45 meter, and
Yeah.
width, minimum width is like around 26 meter, which is very low compared to the
Yeah,
FIFA
so you can
quality.
use it for
And
small fields, and generally speaking, the requirements, as you'd imagine at FIFA Basic, are less. There's more flexibility in the numbers that you can get. So it's I suppose it's an easier. Uh, it's still quite rigorous actually. It's not easy to pass, but it's easier to pass a FIFA Basic test than a quality pro test. Yeah.
Well, we still have a few questions before the end of the webinar. David, do we have a ready-made comparison chart, artificial turf versus natural grass?
I don't have a ready-made one. I think I would say the following though. Both surfaces are great. Okay, they've got but they are different in their characteristics. You see fundamental, and again, as a mechanical engineer, you've just got very different materials. One is kind of natural grass, sand, organic matter, root zone, okay, and soil, and that has it's really it's a plastic system. Okay, if you do an impact, it doesn't spring back. Yeah, okay. Whereas synthetic turf does. They've got different characteristics. Okay. Um, Elite natural turf is amazing, but you know, it's a very complicated thing to have. And in particular climatic conditions, it might be impossible. If you've got an indoor dome or you've got no water or whatever, it's a very hard thing to have in certain climatic conditions. And that's where synthetic turf has key benefits, right? But I don't think I both surfaces are excellent, but I'd say they've got different case uses. It's a bit like the Formula One car. It's amazing, but you wouldn't use your Formula One car to drive around to the shops or on normal roads. You just can't do it. So again, you've got different case uses, and I would never say that one is better than the other because it really depends what you're trying to do with it. And again, what do you mean by natural turf, right? Natural turf has got a huge range from like stitched hybrids, carpet hybrids, fully natural. What type of drainage design have you got in it? What type of sand? Natural turf is a very wide topic as well, just like synthetic turf. Okay. Again, synthetic turf has a wide range of properties. Some synthetic turf systems might have different infills or different shock pads or so forth. So again, I think it's dangerous to say this is natural turf and that's synthetic turf because both are quite variable themselves. Okay, so I think it's a case really of if you have a project that you're trying to do, you're thinking about building something, you talk to an expert. Make sure you've got some expert advice, and not just talking directly maybe to the person who's selling you the field and building the field. I think it's really good to have some independent expert advice in here as well. I'd say, yeah.
Well, on the same subject, maybe a little bit different. Can we explain why international players still feel that playing on natural grass is less prone to injuries then?
Yeah. So, I think you are correct, and I've looked at this extensively. There is a perception. If you take we'll take soccer as one case. There's a perception with elite players that synthetic turf is more injurious, has a higher injury risk than natural turf. Okay, but I refer to something like 108 peer-reviewed studies which have evaluated the injury risk between synthetic turf and natural turf. 108 different studies, okay? And you do a meta-analysis of them, okay, or a systematic review, and there have been systematic reviews and meta-analyses of this. This is proper medical research, and there's no elevation of risk. There's no evidence that synthetic turf has a higher injury risk. It's just not there in the data after 108 different peer-reviewed studies. Okay, so players may perceive it, okay, but if you're an elite player, and this is the thing you've got to be careful about, particularly in Europe, elite players, they go into football academies and their coaches tell them that natural turf is best. Okay, and then, you know, that then drives like a set of behaviors, and they get very used to playing on this really nice natural turf, and then synthetic turf is different. Okay. But, you know, there's just no evidence in the scientific literature. I'm a scientist. I follow the literature. If someone can show me a good study which shows that synthetic turf has an elevated injury risk, fine, I'll start saying something different. But, you know, after 108 peer-reviewed published studies, no one's done it yet. So I follow the science, and the data says something different. So there's a miss. I think sometimes players, if you're not, that's the other thing I want to mention. If you are athletes get conditioned to a certain surface. So if you always train on a soft surface, so typically I would say synthetic turf is a bit softer than natural turf, okay? If you're always training on a relatively soft surface, if you then go and play and do a maximal effort on a hard surface, there may be an elevated injury risk. Again, if you always train on a hard surface and then you go and play on a soft surface that you're not used to, they might have an elevated injury risk because you're not conditioned to the surface. But you cannot say that one surface is a higher risk than the other. It's just that your body isn't well prepared for that surface. And that might be something that happens in some cases as well. But a good athlete will train on different surface types, basically. Yeah.
Thank you, David. I have a question about SBR, like infill matter. In India, we use infill silica sand and SBR as infill. Players sometimes mentions that SBR radiates heat and becomes uncomfortable for playing over a period. Is it true? And does it require an irrigation system to dissipate the heat?
Yeah. It's true that SBR does look. First of all, let's just do some basic stuff here, right? When it's hot, it's hot. Everything's hot. So and particularly the ground is hot. So that, you know, you've got the radiation coming down, and that is then being absorbed in the ground. And if it's say 30 centigrade, I know in India it's often 40, 45, but if it's say 30 centigrade outside, ambient temperature, the surface temperature could be, and this is on any surface, could be like 50, 55, 60 degrees. It could be very hot because the sun is radiating down on the surface. So the surface gets hot no matter what it is. But for sure, SBR is black, right? Black then doesn't reflect light, it absorbs light. So the actual granules can get even hotter. Okay. And, you know, yeah, I'd say SBR fields are going to be hotter than, say, a natural turf field in extreme heat. They are. Now, you can have different types of infill. This is where organic infills do perform very well. An organic infill, so you don't have to use SBR. You could use a cork system or a pine system. There are many different infills available now, like this sort of so-called kind of corn on the cob infill. There's all sorts of, you know, olive pips. There's a number of different organic infills that are actually cooler in extreme heat. Okay, but again, I just be careful. They're good in extreme heat, but they're not good when it freezes in winter. If you're in that climate, and also they do tend to, because they've got a lower density, they can float under very, very extreme rain conditions. So it really depends on what your environment is. Okay. But it is true that SBR infill it's black and it absorbs UV and it does get hot. And again, I mean, if you look at states like Texas in America, they, you know, a lot of them are moving to kind of pine organic type infills where they can, because they think they're a bit cooler. But again, they're not worried about monsoon events, and they're not worried about freezing events there. So you've got to, it's why you've really got to pick your system carefully.
All right. There was still a couple of interesting questions. Isn't hybrid pitch preferred surface for all FIFA top competitions?
So a hybrid pitch, was that?
Hybrid pitch, yeah.
A hybrid pitch, yeah. I haven't really, I glossed over this. So hybrid stitched systems are now really, really popular in elite football. Very, very popular in Northern Europe. And how would I describe this? So a lot of the, if you think about a lot of tournaments in FIFA world, the people who are kind of making decisions, often they have come from Europe, I'll be honest with you. And they do have that experience of stitching or using carpet hybrids for elite tournaments. And so now, if you take FIFA tournaments, they're almost always stitched or carpet hybrids now. They believe that, and there's good evidence for this, they're more consistent. Which means they're more similar to each other. They're more similar across time. Also, they can just withstand the traffic. Basically, they stand up during the tournament better. It's really, it's become the way it's done. Yeah. So essentially, what you have is you build your football pitch in sand. So you get a big sand profile. So it drains amazingly well. And then essentially, you stitch plastic fibers if it's a stitch system. Okay, to create the shear strength in that system, so the sand doesn't just fall apart, and that's become a really very popular way to create a very an elite high-end system. But again, that is they're very expensive. They take an awful lot of energy and input. If you're a Premier League football club, great, but if you're a local municipality, it's probably not going to work for you.
Okay. How much does run-off dimension play a part with certification of field like hockey and football? If that makes sense.
Yeah. There are minimum requirements for run-off dimensions. So I don't want to say the wrong thing here, but football, soccer, like 3 meters as a run-off. I think rugby's like 5-meter runoffs. Yeah, the runoff is part of the playing field, and actually, there's a lot of focus on the runoffs because, unfortunately, sometimes players do get injured in the runoffs. There was a tragic case recently, actually, in the UK, where a player, the runoff was I think it was like 2 meters, not the regulation 3, and the player ran into a wall, hit his head and died. So the runoff, the dimension of it, and in rugby, you can imagine players are going over head first out of the field of play. The runoff is considered to be part of the field of play from our perspective. We test the runoffs, we test the properties of the runoffs, and there are minimum dimensions based on what the sport needs to keep the players safe. Yeah, it's often a big topic, and if particularly if we're the classic example is you're trying to put like a football pitch inside an athletics track, and are the runoffs going to be big enough or not? It's a really important topic to get it right. Otherwise, that can be a big problem, and it's fundamentally a player safety topic because players get hurt if the runoffs are not well if they don't have the right characteristics, but also if they're not the right dimensions as well. Yeah.
Okay. David, for synthetic turf products, what are the different types of backing material and which among them is the best? How is polypropylene backing in terms of durability compared to other types?
You know what? A great technical question. I think what I'd prefer to do is maybe whoever's asked that question, we'll take that. I got a couple of experts in my team. I don't want to give you a bullshit answer because I don't really know. Sorry to be rude, to be crude, but I think I'd rather take that question, pass it to maybe one of my experts inside. I'm thinking maybe my lab manager in the UK, David Rigby, is probably pretty good on that. And so I'll if we can take the name and the question, we'll get back to you on that. But I don't
Definitely.
have a personal expertise on that, so I don't want to say the wrong thing.
All right. Are there, I think this is the last question we have for now. Are there chances of slipping on a synthetic turf surface while twisting and turning on the field while playing, and which systems of turf are best to overcome that?
Okay. So grip slippiness. Yeah. Okay. This will be the final question. I'll just say a few things about grip. So if you consider what grip is, so we want to make sure that players have enough grip so that they can perform accelerations, forwards, backwards, lateral, side cuts without slipping. Okay, so you've got to have enough grip. So if we think of like an injury risk kind of graph, if you have the amount of grip sort of increasing horizontally and an injury risk vertically, if you have too little grip, you will have a very high injury risk. As the grip increases, injury risk will go down because you're in control. You're not falling over. You're not slipping. And then essentially, as the traction available grip goes up, injury risk will actually also go up. Okay, and that's because if you have too much grip, you will have like so-called a stiction event, and the players will not be able to twist properly, and you may create excessive joint loading. Okay. And that's typically linked to like ACL injuries and so forth. So this is well proven. I've done a lot of this research myself at University of Sheffield and so forth, and we know that there's this kind of injury profile, right? And you want to basically have the right amount. You want to be in this low injury zone, right, where you have enough grip for performance, but not too little and not too much. And that's why we have thresholds. So we know that, say, 30 to 50 Newton meters of peak torque with our device, that is what we think to be a range which promotes high performance for the athletes, but it doesn't elevate the injury risk as well. So if your system can pass between that, say, 30 and 50 Newton meters range, it's almost certainly going to be good for the players. Okay. Now you said which systems are better, which ones are worse. Okay. Again, every turf system, it really depends on how much sand, how much infill, what's the pile height, what's the pile density. There's many different factors that can lead to it. But generally speaking, what we would see is that like a polymeric infill is almost always fine. You do pretty well. Organic infills, some of these like corks and olives and so forth, they can have quite high grip. So they're on the higher end. But if you manage it well, it's still okay. But they typically can be quite a bit higher. Non-filled systems or systems with just a mineral sand dressing, these sort of so-called 4G systems, they can have a lower grip. So that's typically what we see. But again, you get innovation, you get products which kind of buck that trend as well. But as long as it falls within the range that we know is promotes safe play, you're okay. So but it's why testing is important, to make sure you get between that sort of 30 and 50 Newton meters range. Yeah.
Okay, we are a little bit over time. David, do you agree if we take one last question and then
it will be the last one. It must be the last one.
The last one, and then you can contact us. Then reach out if you want to discuss any topics. So from Richard Page, from your knowledge, David, what are the main causes for the joint lines on the carpet opening over time on the field that is only 2 years old?
Okay, I want to be careful who's on the line here. I would say, that seems a problem with glue, right? So either a problem during the construction phase, either the temperature or the humidity was a problem during the construction phase. I mean, when we do a product ID, we do test the joint strength. So we test a joint in the laboratory. We have the tensile bench and we test the amount of force it requires to open the seams. I'd say in Europe we haven't seen many problems like that. I don't know if Anuj can come in more locally in Southeast Asia. Is this been a problem? Seams opening after 2 years, Anuj? Do you see that or?
Yeah. There are sometimes there are some problems with the seam opening, and also, sometimes we feel when the weather is very hot, so we can see a lot of wrinkles, especially on the hockey turf, you know.
You got
But
expansion in
when
the
the
system. Okay.
yeah, but when it's not very hot, so you can't see too many wrinkles sometimes, and but yeah.
Again, I don't have an amazing answer for that, other than I'm almost certain it would be to do with the construction and probably the conditions as the glue was setting in the seam, I think. Again, we could take that. I could try and maybe I've got my team in Asia might have some better answers for that. That's something that isn't particularly seen. I'm sorry, where I am. Okay, I travel the world all the time, but I am based in Europe. We don't typically see that problem in Europe so much.
Okay, good. I think we'll be over for now. Thank you for your time,
Okay.
David. And if you wanted maybe to say your last word.
Yeah, so I think we took, a lot of questions, which is great. We have a lot of different questions, which is good. So as we come to the close of this webinar, so on the behalf of, Labosport India, I would like to thank our speaker, Professor David James, for taking the time to share his knowledge and expertise with us today. Next, I would like to thank the co-promoter of this event, Sports Engineering Association of India, for be the co-promoter. And then our participants, most importantly, thank you for your active engagement and thoughtful questions. So we hope this session has been informative and helpful to all of you. And if you have any further questions and the feedback also, so please write us to via email, and the recording of the session we will share you after this meeting end. And thank you once again with us being with us today, and stay safe, stay connected. That's all.
Thank you, everyone.
Great. Thanks, everybody.
See you soon.
Have a good day. Thank you.
Thank you.